Because I know most of you aren't even thinking a whole lot. Sure. Can anybody out there tell me what a net is? By the way, the little subheading is a net of what? Pyramids, cones, prisms. Anybody looking in the book?
Prisms,
cylinders, pyramids, cones. Prisms, cylinders, pyramids, cones. Cylinders, pyramids, and cones. Anybody know what a net is? Besides something you catch people in? A net, somebody going once, going twice. You know, sometimes kids are just not very talkative. Let's see, how about those people? Somebody that actually showed the work. Dervis. Something you can take apart. This is not say what a net is. What is the exact definition? The book gives no very good explanation. And basically what it is flattening a 3D shape so you could make it, I guess. That makes no sense to me, but I'll show you what I mean here. In other words, let's say you've got a prism, which happens to be a box. Okay, I've got my three-dimensional box right here. By the way, you could get a job doing this because obviously, okay, the company that wanted to ship this bulb for this projector had to design a box that you could put the bulb in and ship it somewhere. And when they design a box, they must design a box so that a cardboard company can make that box. Okay? And what happens is, obviously the cardboard company needs to know cardboard comes in flat pieces that have to be shaped and molded to this. So the net is, what is the shape? What, if you flatten this out in a flat piece, that when you put it together again, you get that three-dimensional object. This is what the net of this would look like. And there's different ways you can do it. This is not an exact thing. No. They got some tape. Apparently they didn't think about the guy that had to take the box apart. Just hold on a second. Where did it go? Oh, I needed to cut one more cut here. Tape! Somebody tape! My kingdom for some tape. Remember what tape looks like? Wait, did it just fall apart here? Where did the bottom go? I want to do that. That's perfect. Let's do that. The problem is I can't do it like this. Hold on a second. What would a tissue box look like unfolded?
Like that would involve it.
I don't think it will, sir. I'll do it like this. So here you go. I just got to keep my top together. Don't you worry. I've done this numerous times before. What does a tissue box look like? When it's unfolded. What is the net of a tissue box? This one will stay together. There we go. Fine. The net of a tissue box. Okay, you've got this bottom, and there's numerous ways that this could have been cut and you get the same thing. But when the cardboard company makes this box, no, there's obviously a lot of other things that go into it. Okay, but they need a blank piece of cardboard that ends up looking like this, so that when it goes into their little folding machine, it folds it in those right places and glues it in those right places and blah, blah, blah. It's a lot more complicated than that. But that's what a net is. Really, when you find surface area of something, you are looking at all the different sides that a net would give you. I mean, if you look at this, when we did this box here, this was the bottom. This was the top. You know, this would be the, I don't know, it doesn't matter. This could be the front and the back and the right side and the left side. When you put it all together, you get the box. Now, you have to think a little three-dimensionally there. What would a cylinder look like if somebody was making it out of cardboard? What would be the net of a cylinder? Well, if you look at a cylinder, it's not that terribly difficult. If you look at a net of a cylinder, okay, you've got two shapes that are obviously what? Circles. The top and the bottom are circles. I guess I should draw better circles than that. A circle and a circle, and then what is the side of this cylinder going to look like? It's going to be nothing more than a rectangle. And it wouldn't matter where you put the circles on that rectangle. The circles could be here and there or wherever. Okay, but this is the label of the can. And this is the top circle and the bottom circle. This is the net of a circle or a cylinder. What would the net of a pyramid look like? Let's say I've got a square pyramid. What would the net of that look like? Again, multiple ways you could actually do this. I'll do it two different ways. Landon, it would look like?
Square with like triangle axes.
Yeah, one way to draw it would be like this, and then off of every square is a triangle. But another way to think about it, if you kept these points connected there, you could draw the net of it to look like this. That's a little big. And then the bottom would get attached to just one of them. Realistically, that could be the net of that same triangular prism. And then what was the last one? A cone. What would be the net of a cone? What happens? What would the side of a cone? Obviously, the bottom of a cone is a circle. But what happens when you have a cone? When you cut it down the sides, what shape do you get? Somebody going once, go twice. I need a piece of paper. This one. I'm going to make a cone. I'll try this at home. Can I make a cone? Is that a good cone? Not really. I'll fix it. Should go to the run. I'm here for you. What happens, ladies and gentlemen, if you take a cone and you slice it down the side so you can lay it flat? What shape dost thou get?
Triangle.
triangular-like looking sort of shape here. So you end up with something that looks like that. Which looks like a lamp. Shade a little light bulb in there. And I think, let me see what questions they actually ask you. They might ask you this. Sketch the net. Look in your books on page 378, please. Look at example letter D. It says sketch the back, top, and right side views of this triangular prism. So let me draw that out for you here. You've got a right angle here, and you have this thing that looks like this. And you can't see this back here. Think about this. The book asks you to do a couple things. Sketch the back, top, and right side. The back, the top, and the right side. You have to think a little bit in the fourth or fifth or eighth dimension here. Where's the back of this shape? It's this back that you cannot see. If, does this have dimensions? It does. 5, 6, 4, and 3. 5, 6, 4. What shape is the back of that triangular prism? Alex?
A rectangle.
It is a rectangle. So if I'm sketching the back, what does it look like? It is a rectangle that looks like this. What are the rectangle's dimensions? 3 by 6. You get that? You can't see the back, but you know it's there, and you know what it looks like because it is a rectangular prism. Do I have one of those? This is an awful mess today. Thought I had one. Yeah, okay. I don't have it. What would the top look like if you were standing above this shape looking down on it? What would the top look like? Make you nervous? Brian?
Your in-depth rectangle.
And then depth. It would just be this. This would be the top of it. And it would just be a rectangle again. You wouldn't see this because this is, you're looking straight down on this side. You wouldn't see any in or out. The top would be a 5 by 6 rectangle. And if you looked at the right side, what shape would it be? Just looking at the right side, it is, David? Triangle. Yeah, it's this triangle right here. So the right side would look like this. It's this triangle with a 3 and 4 there. And then if you were sketching a net for it, right now on your paper, I want you to sketch me the net of this. Sketch me the net of that. I will redraw it right here. Straight up and down, come across. Sketch me the net of that triangular prism. There's no wrong or right way to do it. Definitely has 5 different sides. Is that not right? Yes. Andrew Stufer, what did you start with? What's in the middle of your neck?
Rectangle.
Is it the back or the bottom? Okay. Bottom rectangle. Andrew starts with his bottom rectangle, which is this one right here. And then what? Did you connect something to this side?
Yes.
What was it?
The triangle.
Triangle. And your triangle should have probably looked like this. Correct?
Oh, I had it the other way.
So you can do it that way. You're saying you did this?
Yeah.
Okay, I'll go with that. It would work that way. Did you do the same thing on the other side? So you'd have another triangle. This back side over here would be the same thing on this side. So now I've got my base and my two triangles going up there. And then where did you connect the back and the front?
On top of the middle.
Here? Just one rectangle going up?
Yeah.
Did
Well,
you?
no, two.
Two of them. Yeah, and you could do that, that would be perfectly okay. You could have done one on top and connected the other one down here. Technically, you could have put one rectangle shooting off like this, and another rectangle shooting off where? On the bottom like this, if you really wanted to. More than one way to net a cat, as they say in the math world. Perfect. Now, had I not had a lot of people not show their work on this, I would have let you go free, but unfortunately, I would like for you to do problems 7 through 11 on 55 for tomorrow. 7 through 11 on 55. I may ask you again tomorrow if you polish your work or not. And you may go with that. Fortunately, you do have break, right? You already have break? Now that's a bumper. 7 through 11, please.
I sat here and he was like, what's this doing? I don't know. Oh, thanks. Even though jokes is not funny, sounds there. Then I was like, just ask no one. I was like, just ask no one. She was like, wait, why didn't you ask no one? I was like, because he's better at explaining it. Kind of dish it off. I sat there.
Hopefully. Wait, I can turn course by it.
staple line here. Hello, purple piece leaders. Do you guys like being purple people leaders? Oh. It's not like that. Honestly, we do. We must be 65. 62. It's not like that.
No one.
I didn't. Okay. Physically, it was yeah, I remember on that. Oh yeah.
Pick a number, please. Carol?
2.
2? Yeah.
3.
Grant?
30.
What's that?
30.
You close that door, please. April?
60s.
Wait.
21.
Wait. Sorry, what's wrong?
8.
What's that?
8.
9? Tyler?
7 times 4.
Tyler?
30. 30's already good.
Already picked 30.
Oh, sorry.
Carter?
18.
Jack?
Square root of 64. Let's say next time.
Kenzie?
15.
Bryce? Larry? Oh, there must be finals day.
That's kind of best, Mr. Mine. Right angles over there?
It was a net. Let's show them the different ways you could draw and have a triangular prism. That's obviously, isn't that
A net? Yeah, it's triangular prism.
N-E-T.
Oh,
Not net as in trouble.
okay.
This is all of them, all 15 fifth graders.
We're tiny.
Do you set them up every other chair, or is that the way they just?
Yes.
Obnoxious.
One person at a table.
We all get our own table.
See all the space they got? So many classes with only 15.
Nobody likes math.
It can be. That was harsh, Mr. Hahn.
Oh. Oh. Drop my daughter. See you later. Parker. Here we go. Here's where you go. Evelyn, Mackenzie, Carolyn, Carter Westfall, Layla, Wade, Tyler, Parker, Jack, Abram, Bryce, Carter A, Faith, Amelia.
Hi, buddy. Can I ask them? Oh, hi, Tyler. They're hot. Wow, next to each other. Those are tissues.
Here we go, number 1. Jack, some of that is highly confidential and only given out as an as-needed, no basis.
Oh.
But the answer is yes.
Yeah.
We will have a test. When it will be,
Question.
number 1 should either be a rectangle or a square. Number 2 would be 15 players. 15 players. Number 3, use a formula to find the perimeter. Basically, the formula would be 100 plus 40 plus 100 plus 40. In any order of those, you get 280 yards. Sure, 100 times 2 plus 40 times 2. That'd be the same. 4 is 9 inches, and 1/4 of a yard is 25%. 9 inches, 25%. 5 is 45 minutes. 6 is 1,500. 7A is 1/10. B is 9/10. C, when you add 1/10 and 9/10 together, you get 1, which is what you would start with. Number 8 is 1.32. 1.32. Generally not. I don't know why you
Could
put
it be
it.
132 centimeters?
No, it said what is it in meters.
Oh.
Number 9 is 5 decimeters. A whole meter is 10 decimeters. Half of a meter would be 5 decimeters. 10 in order from least to greatest. You get 3/8, 5/10, 2/3, and 4/4. Number 11, the number 10 has 4 factors. Doesn't ask you to give them, just ask you how many it has. 12, you get 3 3/4. 3 3/4. 13,543 is the greatest odd number. 543. 14 is 105. 105. 15, 96,005. 96,005. 16 is 1,483. 1,483. 17, 291,232. 291,232. 18, 659, remainder 1. 659, remainder 1. 19 is 84 cents. 84 cents. Number 20 is 168. 168. 21 is 9. 21 is 9. 22 is 1 5/8. 1 5/8. 23 is 3/4. 3/4. 24, 5,040. 5,040. 25 is $2.37. $2.37. 26 is 30 eggs. 30 eggs. 27, 1,080 is divisible by all of them. 2, 3, 5, 6, 9, and 10. Number 29, what's the probability with one spin the outcome will be an even number? 2/4 or 1/2. 28, sorry. 28A is 2/4 or 1/2. B, the probability the outcome will be less than 4 is 3/4. B is 3/4. Letter C, the probability that one spin the outcome will be a number less than 5, that would be 1. Probability of 1. It will happen.
Could we write 4/4?
No, 4/4 is 1, right? 1 next time. Number 29 is about 20 degrees cooler. And 30 is 15 minutes. 15 minutes later. 28A is 2/4 or 1/2. Abram?
It says to use the spinner.
For 20 to 30?
Yeah. No, refer to the 28 to 30. 28 to 30.
Refer to the spinner. Okay, what's your question?
I don't think 29 to 30 is.
What's that?
I don't think.
Oh, I agree.
Maybe.
So you adjust. So you just use it for 28. You don't need it for 29 or 30.
Maybe it was trying to say refer to ABC. Yeah. No.
That could be very well true. Other questions?
No.
Ken?
20 and 28.
20 is 168. And which one?
28.
A is 2/4 or 1/2. B is 3/4. C is 1. Carter?
9.
9 is 5. Right?
17.
17 is 291,232. And the other ones. All right, take out your notes under measuring again.